Okay, good morning class. So today we're looking at probability, chapter 20. We're looking at the examples for exercise 2. And exercise 2 is on page 316. Okay. Now you're going to ask yourself why we're going straight into exercise 2. Because exercise 1 deals with exactly grade 8 probability, which we discovered. Okay? So if you want to the revision on this, you can find the links in the description box below. Okay? So today we're going to look at compound events. Compound events. A compound event consists of 2 or more sample events. For example, tossing a die once is a sample event. The outcomes are 1, 2, 3, 4, 5, and 6. However, tossing a coin on the second time and stating the outcomes of tossing a coin twice is called a compound event. Okay? There are many more outcomes in this compound event. For example, one outcome is getting the number 3 followed by the number 6. We will discuss an example of this experiment later on in this chapter. The outcome of the compound events can be represented one of 2 ways, is either a 2-way table or a tree diagram. We're going to look at both. Okay. Example of the following will illustrate how to determine the probability of compound events, 2-way table and a tree diagram. Example 1. And example 1 is on page 313. So suppose a coin is tossed twice. Okay. So now we are asked to draw a 2-way table to represent all possible outcomes in the sample space. So let's look at a table. Not because we're hungry all the time, no. Right. So the first coin. What are your outcomes if I toss a coin? Could either be, this is the first coin, could either be heads or not so. On the second coin, what are my outcomes? Sorry? I could either have heads or tails. Not so. So, if the first coin is heads, the second coin could be heads as well. Not so. Or if the first coin is heads, the second coin could be tails. If the first coin is tails, then of course the second coin could be heads, tails and heads. Then why did I write? I could have written tails. But I write tails head so that I don't miss out on any outcomes. Do you see that? And then it could be tails. People, you guys understand? So how many outcomes are there? There are 4 outcomes. What's the chance of us landing on a heads? 1 out of 4. What's the chance of getting a heads and a tails or a tails and a heads? 2 out of? You guys understand? And this is a 2-way table. One way is the first event, second way is the second event. You guys understand? Let's look at B. Draw a tree diagram to represent all possible outcomes in the sample space. People, we have seen people draw apple trees already. That's not a tree diagram, okay? This is a tree diagram. What do we do? It's your branches. You see that? What are my outcomes? What are my outcomes? If I toss a coin, either be Heads or tails. Now this is the first coin. First event, the first coin. So if you toss heads on your first account, then on the second toss it could be heads or tails again. If I toss tails on my first toss, my second one could either be heads or tails. And this is your second second toss or second coin. You guys understand? I do not have to write this in here. Right. So, what is the probability of tossing a heads on your first toss? Sorry? 1 out of 2. And tails? 1 out of 2. What's a half plus a half? 1. Can you see that wherever that branches meet, we're always giving an answer of 1. Okay. What is the probability of me tossing a heads on the first, on the second coin? Sorry? 1 out of 2 is. And tails? 1 out of 2. If I toss tails on my first coin, what is the probability of tossing heads on the second coin? 1 out of 2. And? So if I follow these branches, so that could be heads, 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 tails. So this one is exhausted. Right? Then it could be tails, heads, or tails, tails. Guys understand? Is there any confusion? Yes? Is there any confusion? No? Easy, no? So now C says, using the two-way table and the tree diagram, determine the probability of obtaining a heads on the first toss. Heads on the first toss. So it's going to be 1 out of 2. That's one way I could have looked at if I used the tree diagram. Otherwise, heads on the first toss. Where's heads on the first toss? There and there. So it's going to be 2 out of 4, which is half anyway. You guys understand? Right. Number 2. A tail on the first toss. Tail on the first toss is half. Or 2 out of 4, which is half. Number 3. A head followed by a head. So it can only be heads, heads. Not so. So that would simply be 1 out of 4. That's why we use the tree diagram. So that would have been probability of heads times the probability of heads. What's the probability of heads here? Half. The probability of heads here? Half. Which is quarter. Same. You guys understand? Number 4. A heads and a tails in any order. Heads or tails in any order. Heads followed by tails. So how do we do that one? So you can be tails, heads, or heads, tails. Not so. The probability is going to be tail, heads, or heads, tails. So it will be 2 out of 4, which is, let's use then the tree diagram. So it's going to be heads, tails, or tails, heads. Not so. So what's the probability of heads? Half. Probability of tails? Half. Which is a quarter. Probability of tails half. Probability of heads half. Which is a quarter. What's a quarter plus a quarter? 2 quarters. Which is half. You guys understand? Number 4. Number 5. No heads. P, H, no. How many heads are there? 3. 3 outcomes it has heads on them. Not so. So how many no heads are there? 1 out of. So no heads, of course, is tails. Okay, so it's going to be half times half, which is a quarter anyway. Number 6. At least one head. So it's that one plus that one plus that one. Not so. So in other words, it's going to be 3 out of 4. At least one head, it could be 2 heads as well. So it's going to be 3 out of 4. Okay? So it's going to be 3 out of 4. Otherwise, if I go on with this one here, it's going to be half times half, a quarter. So that's a quarter, and that's a quarter. So a quarter plus a quarter plus a quarter is 3 quarters. Which will give you the same answer. You guys understand? Now, would we use both all the time? No, we would use one of the two. Okay? They'll either tell you draw a tree diagram or a what's the name, and then answer the question. Now we are told, suppose a coin is tossed 3 times. Now, not talking about a two-way table now. You can see it's only talking about a tree diagram. So the two-way table, you can only have 2 events happening. Can you see that? Whereas a tree diagram, you can have many ways, many things happening at once. Okay? You guys understand? So let's go. Suppose that the coin is tossed 3 times. Draw a tree diagram to represent all possible outcomes in the sampled space. So let's go. So if you toss the coin in the first event, what would it be? Heads or tails? What's the probability? Of? So that's your first event, not so? In the second event, it can either be heads or tails, or heads or tails. What's the probability here? Half and half. Half and half. Not so. So that is after the second event. In the third one, it could either be the third account could either be heads or tails. So it's half and half. Again, heads or tails, half and half. Heads or tails, half and half. Heads or tails, half and half. What are my outcomes? It could be heads, heads, heads. Or heads, heads, tails. I could have one tails, 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 but I might lose a combination there. Can you see that? The next one, heads, tails, heads. So I'm just going to mark up what I've done so you can see. Heads, tails, heads. Then heads, tails, tails. So I've exhausted all of this here. Then it could be tails, heads, heads. Then tails, heads, tails. Then tails, tails, heads. Then tails, tails, tails. How many outcomes are here? 1, 2, 3, 4, 5, 6, 7, 8. You don't have to write this. You don't normally write. Okay? Any confusion at this point? B. B says, using a tree diagram, determine the probability of, in the first case, obtaining 3 heads. So what's the probability of hitting heads on the first one? Second one? The third toss? So it's going to be 1 out of. That's one way of looking at it. Otherwise, you could have said 3 heads. That's the only one with 3 heads. So it's 1 out of 8. You guys understand? Let's look at B. And number 2, sorry. B2. 2 tails followed by a head. So there has to be 2 tails followed by a head. 2 tails followed by a head. How many fit that condition? Huh? 1. 2 tails followed by a head. So that must be in that order. So it's going to be tails, tails, heads. Is 1 out of. Number 3. 2 heads and a tail in any order. Now, he didn't have to say in any order. We'll just say 2 heads and a tail. Then we would have known it's any order. If they specify, like here, followed by a head, then it can only be that. But without specification, you can consider all. You guys understand? So let's go. 2 heads and a tails. 2 heads and a tails in that one. 1, 2, 3. 2 heads and a tail. Wait. 3. I'm getting 3. Somebody said 4. So probability of 2 heads and a tail. Okay, so that's going to give you 3 out of. Number 4. Number 4, at least 1 tail. At least 1 tail. At least 1 tail. This shouldn't be here, no? No heads. Let's probably say no heads only.
Your attention, please.
Azra
Pakir, can you please report to the office?
You want to agree that?
Please report to the office.
No heads only. That means to say they are omitting this one. Okay. So it says at least 1 tail. So it could be, there's 1, 2. Could it be 2 tails? At least 1. So it can be 2 and 3. It can be 2, yes. So 3, 4, 5, 6. Can you consider this one? Tails only? So it's going to be, the probability will simply be 7 out of. People, any confusion there? For homework, I would like you guys to do exercise 2.
Please. The following
Which is on page 316.
Report to the reception area now. Under blessing.
The full lesson can be found in the description box below.